The advantage of quantum mechanics is you can apply this actually to macroscopic as well as microscopic objects. That is the advantage of quantum mechanics. Okay, so we will be actually dealing with quantum mechanics like topics like Schrodinger's wave equation, time dependent, time independent, and then de Broglie wavelength. Okay, all these things we will be dealing with. Okay, so we will see now what is the difference between visible light and then thermal radiation. Okay, quantized energy of light is actually photon, and thermal radiation, it is quantized energy of thermal radiation is phonon. I already told you thermal lattice vibrations are phonons. So quantized energy of these light particles are called photons. Thermal and light radiation are identical. The only difference is of wavelength. Okay, the wavelength of visible light is smaller than that of thermal radiation. Okay, I already, we have discussed several times that E is equal to h nu. Energy is equal to Planck's constant multiplied by frequency. Nu is frequency of the wave, whatever it is. Emitted energy in the multiples of small unit called quantum or photon. Okay, Planck, E is equal to h nu is Planck's law. So radiation energy absorbed or emitted in packets of h nu. What is de Broglie wave? We will be going through some basics so that you can understand better. De Broglie wave means moving particle. Moving particle in the sense, let's say electron. Electron that is associated with wave. Electron, this particle movement will be like a wave. So the particle associated, moving particle associated with wave known as de Broglie wave. Okay, so how do we actually represent? You just try to put a dot on the paper and then try to connect in the form of wave. So that is called de Broglie wave. So lambda is equal to h by mv, mass into velocity of the particle. H is Planck's constant. Wavelength of the material particle is equal to h by mv, which is also equal to h by p. Okay. We will try to now derive expression for de Broglie wave. De Broglie wavelength. Planck's theory, according to Planck's theory, energy of a photon E is equal to h2. That is equal to h nu means c by lambda, hc by lambda. According to Einstein, E is equal to mc square. Okay, then E is equal to h nu, that is equal to mc square. M is equal to h nu by c square. Mc square is equal to h nu. You can write now. So mc square is equal to h into c by lambda. Then mc is equal to h by lambda, which is lambda is equal to h by mc. What we are trying to derive now? We are trying to derive de Broglie wavelength lambda. Lambda is equal to h by mc. mc is equal to p. Mass into velocity. Here, velocity of what? Light particle. That's why it is c. Yeah, mass into c. M into c is equal to p. Momentum associated with photon. Material particle of mass m and moving with velocity v. Then mv will be the momentum of the particle. So lambda is equal to h by mv, which is equal to h by p. If E is the kinetic energy of the material particle, then E is equal to half mv square. Kinetic energy equation is half mv square. That is equal to half into m square v square by m. That is equal to mv means p. P is equal to mv, right? So half p square by m. Then E is equal to p square by 2m. 2me is equal to p square. Then p is equal to root 2me. So de Broglie wavelength lambda is equal to h by p. What is p? H by square root of 2me. Just now we derived. So when a charged particle carrying a charge q is accelerated by a potential difference of v volts, then its kinetic energy is E is equal to q into v. Okay. Charge q, material particle charge is q. Let's say electron charge. Its charge is Q. V is the potential difference that you have applied. Okay. So lambda is equal to H by square root of 2me, the earlier equation we derived. There, what you substitute instead of E, you write Q into V. Then H by square root of 2m into QV, which is lambda. So we have derived 1, 2, 3, 4 equations till now. We will see what other equation can be fit for this de Broglie wavelength. When a material particle is in thermal equilibrium at a temperature T, then E is equal to 3 by 2 kT. K is equal to, what is this Boltzmann constant? 1 by 1.38 into 10 power minus 23 joule per Kelvin. So the de Broglie wavelength of a material particle at temperature T is given by H is equal, lambda is equal to H by square root of 2me. No? Here, instead of E, you write 3 by 2 kT. Then what you get? H by square root of 3m kT, which is equal to lambda. Okay. So, since we are talking about material particles and then light photons, we'll just now try to understand what is photon. Photons are electrically neutral. They cannot be deflected by electric or magnetic fields. Okay, they cannot be deflected by electric or magnetic fields. Moreover, they do not ionize also. They are electrically neutral particles. Okay, fine. We'll see de Broglie wavelength associated with electrons. We'll try to see. We'll substitute what is its mass, this, that, and all, and then we try to conclude its wavelength. Okay. So let us consider that case of an electron of rest mass m0 and charge E, which is accelerated by potential V volts from rest to velocity V. Then half m0 V square is equal to E into V. Okay. That is, then V is equal to square root of 2 EV by m0. Now lambda is equal to H by m0 V. Okay. m0 means rest mass. That's why it is m0. Otherwise, it is simply m. H into square root of m0 by m0 into square root of 2 EV. Okay, we are all simplifying it. Here V, this equation we have substituted here. V is equal to square root of 2 EV by square root of m0. We have substituted here. So we got this. So if you simplify further, square root of m0 by m0, in the sense, if you simplify, what you get? H by square root of m0 into square root of 2 EV. That is equal to H by square root of 2 m0 EV we get. What is H? Planck's constant value. 6.625 into 10 power minus 34 divided by square root of 2 into m0. Rest mass of the electron. What is that? 1.632 into 10 power minus 10 volts. Okay. Multiplied by, what is that? m0 E V. Okay. E, we wrote m0 9.1 into 10 power minus 31. This is E, 1.6 into 10 power minus 10 volts. It is E multiplied by 9.1 into 10 power minus 31. You have substituted everything. Then we get 12.26 by square root of V angstroms. Here, if V is 100 volts, then what will happen? 12.26 by 100. That means 12.26 by 10 angstroms. That means 1.226 angstroms. Wavelength of the material particle, which is actually we considered here electron. For electron, if it moves in the form of wave, according to de Broglie, its wavelength would be 1.226 angstroms. Okay. So, actually, there are certain things that you should know. Classical mechanics failed to explain the stability of an atom. Okay, because classical mechanics could not explain the material particles like electrons, protons, and other things behavior. But actually, quantum mechanics could do. It doesn't mean that classical mechanics cannot explain macroscopic objects' behavior also. It's not like that. Classical mechanics, of course, holds good for macroscopic objects. Okay. So it failed. So classical mechanics failed to explain spectrum of hydrogen atom, the non-relativistic motion of atoms like electrons, protons, etc. Okay. And origin of discrete spectra of atoms, the spectrum of black body radiation, variation of specific heat of metals and gases, failure to explain photoelectric effect, Compton effect, Zeeman effect, Raman effect, etc. All these things, this classical mechanics or Newtonian mechanics could not explain. Why? Because these are all subatomic particles. By the time you try to find out its position, its momentum would be changed. By the time you find out momentum, its position would be changed. That's why classical mechanics could not explain, because subatomic particles' behavior is entirely different compared to macroscopic objects. According to Heisenberg's uncertainty principle, it is impossible to measure both the position and momentum of a particle simultaneously to any desired degree of accuracy. So delta P into delta X is greater than or equal to H. Okay. Delta P is uncertainty in determining the momentum. Delta X is uncertainty in determining the position of particle. Similarly, delta E into delta T is approximately equal to H. Here, E and T means energy and time. And another equation, according to Heisenberg, delta J into delta theta is approximately equal to H. This is angular momentum and angle. Okay, the product of uncertainties in determining the position and momentum of the particle can never be smaller than the order of H by 4 pi. So, delta X into delta P is greater than or equal to H by 4 pi. Delta E into delta T is greater than or equal to H by 4 pi. Delta J into delta theta is greater than or equal to H by 4 pi.